Hi guys, welcome to round 2 of solving logarithmic equations. We're going to start working through some examples here now that we understand domain. So I know this looks complicated, but it turns out to be fairly simple. Okay, if we're going to solve for x, all we have to do is this. Ready? I see on both sides that I have a logarithm. Everything here has a logarithm. And in fact, I know that the logarithm of the left side, this stuff, is equal to the logarithm of the stuff on the right. So it stands to reason, if the logarithm of this equals the logarithm of this, and these two pieces on here, they must be equal to each other as well, right? So all I have to do, if both things have a logarithm, is just simply drop the logs and say, well, the x plus 9 and the 4x must be equal to each other, because it doesn't make sense any other way, right? If that was a log of 2, that better be a log of 2 in the end. And if this is log of 17, that better be log of 17 in the end. So the x plus 9 and the 4x have to be the same. So to go through and solve, pretty simple. I'm going to subtract x from both sides. 9 is equal to 3x. And if I divide out the 3, that means that x must be 3. Now I do need to go through and I need to check this value. Let's make sure that whenever I put a 3 in, that I get positive values for every single logarithm here. If I put a 3 in here, that's 3 plus 9, and that means I'm doing log of 12. So I'm cool there. That's greater than 0. Over here, if I do 4 times 3, I get a 12 as well. That is also a positive number. And so when all is said and done, I get log of 12 equals log of 12. We're going to be just fine there. We take no different approach here whenever we're working with natural log. Okay, if I have the natural log of the stuff on the left and the natural log of the stuff on the right, everything has a natural log. That means the x plus 2 and the 6 minus x better be equal to each other. If they're not, something's wrong. So I'm just going to set them equal to each other. I'm going to add x to both sides. And that gives me 2x plus 2 on the left. And that gives me a 6 on the right. Let's subtract the 2, so 2x is equal to 4. Let's divide by 2, so a single x is equal to 2. And that is my answer. So let's go through and check it. Do we get positive values for everything? 2 plus 2 is 4. That means I got natural log of 4. Cool there. 6 minus 2 is 4, so that's natural log of 4 on the right-hand side. So we're good. The answer is 2. So there's the first round of videos. What we're going to do in the second round of videos, I'm going to say, well, look here, that doesn't have a log, so we have to take a different approach. And here we have multiple logs on one side. So what do we do in that situation? This one's going to be a little bit tougher. I think that's it for the notes, right? Okay, these two examples will be a little bit tougher, and we're going to check for extraneous solutions on both of them. You're going to find out these problems have some twists to them. So hopefully the first video makes sense. If you got log on every single thing, one log and one log, just drop the logs and work with it.